So here we are going to discuss how to calculate the RMS value and the average value of any arbitrary waveform. So generally we have taken your RMS value and average value for a sinusoidal wave. So which we have calculated was what? Vm divided by root 2, or the maximum value divided by root 2, that we have calculated for sinusoidal wave. When it comes to non-sinusoidal wave or any random wave, then the process, the mechanism will be same, but the process will be different. So let us see here. So first of all, in this problem we need to know that what is the time period of this waveform. So this voltage amplitude is given as plus 5 volt and minus 5 volt, and the total time is t. So here the time period is equals to 8 seconds. That is what given in this question. So time period is 8 seconds. Now one thing we can see here, this wave is symmetric about the 0 axis. So I will write here, it is symmetric about the 0 axis. So that means what? So when it is symmetric about the 0 axis, if we find the average for the average for full cycle is equals to 0. So if we find the average of this wave over this particular area and this particular area, the average will come, the value will be coming 0. So that is why when a wave is symmetric about its 0 axis, then we calculate the average value and the RMS value for the half cycle itself, and the answer will remain same because it is symmetric. The other half is just the negative of the positive cycle. Okay, so here what is the half time period? So half time period is equals to t divided by 2, that is equals to 4 seconds. So we have to do all the calculations with 4 seconds of time. That means this is my t by 2. Okay. Now in this way, to find the average value, so I will write V average, that equals to what? 1 by 4 integration over 0 to 4, that means the half cycle, and V of t. So whatever V of t is there, we have to integrate over dt. Now the problem here is the wave I see here, it is not a one function. So previously we had only a sinusoidal function, so we can write V of t is equals to sin omega t. So easily we can calculate this. In this case, it is not a clear sine wave or any particular function. So what you have to do, we have to break this into 3 different parts. So this is one part, and here this will be your another part. So we have to find what is the equation for all these parts. So that means the average value is calculated as, so here one part will be taken as 0 to 1, and value V1t, I will write V1t dt plus 1 to 3. So why 1 to 3? Because 1 to 3 the waveform is the straight line. So 1 to 3 I will write V2 of t dt plus again 3 to 4 the last part. So this one is the 3 to 4. So this part I will write V3 of t dt. Now we have to find what is the value of V1t, V2t and V3t. So how to find that? So V1t, your V1t is equals to how much? So you can see this is a straight line. Okay. So for a straight line, what is the equation? Equation is, so here I will write y equals to mx plus c is the equation for a straight line. Now in this case, I need to find what is the value of m here. So how to find that? So m is y2 minus y1 divided by x2 minus x1. So this is from the coordinate geometry, plus c. So y equals to this much x plus c. So now what is the value of y2 here? So if this point is 0 comma 0 and this point is your 1 comma 5. Okay, so if I do y2 minus y1, then it will be what? 5 minus 0. So it is 5 minus 0 divided by x2 is how much? 1 minus 0. So 1 minus 0 x plus c. So that implies I will get here y equals to 5x plus c. Now what is the value of c? How to find that? So just put any point in the given figure and then you will find the value of c. So if I apply this 0 0 point here, then 0 is equals to, so 5 into 0 plus c, that implies c equals to 0. Okay, so finally what we are getting? So finally we are getting y equals to mx plus c as what? it is 5 into t, that is it, because c 5x. So, in our case y is v of t and x is your t. So, that is why I will be writing this as 5 into t for what? For 0, t is between 0 to 1. Next we have to find what is v2 of t. Okay. So, what is v2 of t? So, v2 of t you can see this part. Okay. This part is your v2 of t and the value is 5, it is constant. So, directly I will write is equals to 5 for what? For 1 less than equals to t less than equals to 3. For this range the value is 5. Next I have to write v3 of t. So, how to write that? Again you can see, so this part is your v3 of t. So, this part, how to find that? So, similarly here only we can find. So, if I use this function again, so for this case the point here is 3 comma 5 and here the point is 4 comma 0. So, x2 x1 y1 and x2 y2. So, y2 minus y1 will be how much? So, it is 0 minus 5 divided by 4 minus 3. 4 minus 3 is x plus c. So, that implies your y will be equals to how much? Minus 5x plus c. Okay. So, I am doing it for the second one. So, now we got how to get the value of c. So, we can put any point here. So, if we put the point 4 and 0, so how what we can write? That implies 0 is equals to minus 5 into 4 plus c. So, that implies c is equals to how much? C is equals to 20 here you will get. So, what will be the equation now? So, here the equation will be minus 5t plus 20 for what? For 3 greater than equals to 4. So, for this range this is my voltage equation. Now, how to find the average? So, as I have written here, so we will be putting these values here. So, that implies your V average is equals to 1 by 4 first integration of 0 to 1, V1 of t is 5t. So, I will write it little bit down. Okay. So, here V average is equals to 1 by 4. So, integration of 0 to 1. So, V1 of t is 5t, okay, plus sorry dt is there, 5t into dt plus integration of 1 to 3, V2 of t is 5. So, 5 into dt plus integration over 3 to 4, the last one, and V3 of t is minus 5t plus 20. So, this is dt again. Now, this value you can find it individually also, and through calculator also you can find the integration directly. So, let us see how to do that. So, in calculator, first I will write in bracket integration, the first one. So, first one is what? Integration is 1. So, see the calculator screen here. So, 0, then here the x value is 5 and here I will write x. Okay, so, 5x dx this much plus the second one is what? I will write inside the integration, the range is from 1 to 3 and here the value is only 5. So, dx plus again in bracket integration from 3 to 4 and here this value is in bracket minus 5x plus 20. Okay. So, this is correct. Let me just cross check it. So, first is 5x, then it is 1 2 3 5 into dx, yes, then last one is minus 5t plus 20. Okay. So, this value is coming as 15. So, 1 by 4 into 15, that is equals to divided by 4. So, this value is equals to 3.75 volts. So, this is my average voltage. Okay. Next, what I have to find? I have to find the VRMS also. So, how to find VRMS? VRMS is root mean square. So, root mean square of t by 2 integration of 0 to 4 v of t square dt. So, this is the root mean square value. Now, how to find this? So, again I will just write v square RMS here for easy calculation. So, 1 by 4 again integration of 0 to 1. So, 5t whole square plus integration of 1 to 3 dt is there, 1 to 3 5 whole square dt plus integration of minus 5t plus 20 whole square, and here the limit is 0 3 to 4 and here it will be dt. So, the same equation so see the same equation I am just making it to square, so that okay, we will write it again, so that it will be easy. So, first one is your integration of 0 to 1, okay, and here it is square of 5x. So, not 5x, actually we have to give the bracket here, square of complete 5. Okay. So, this I will write 8.33. So, individually you can write and write also, so that you can less confusion will be there. Next integration of 1. So, 5 square is 25 and here limit is 1 to 3. So, this is 50 plus again integration. So, here the expression is minus 5t plus 20 and its square, limit is 3 to 4. So, this value is 1024. Okay. So, 1 by 4 is there. Now, I have to add this. So, equals to then answer plus 50 plus 8.33. So, that is equals to 1 by 4 into 1082.33. Okay. So, next 1082.33 divided by 4. So, that is equals to 270.58, and then we have to find the square root of this. So, V RMS is equals to square root of 270.58. So, square root of the answer, so that is equals to 16.44. It seems somewhere it is wrong, just I need to check it. I think I have given somewhere wrong, because see RMS value cannot be greater than this maximum value. So, somewhere it is wrong. So, let me do it again. The integration I have calculated probably wrong. So, b square RMS 0 to 1 5t square, this is 5, this is minus 5t plus whole square. Okay. So, just let us just write whole equation again. So, integration 0 to 1. So, let me make this bigger screen. So, integration 0 to 1. So, then 5x square plus again integration 1 to 3, and here it is 5 square plus again bracket integration of, so it is 3 to 4, and here it will be minus 5t plus 20 minus 5x minus 5x plus 20 and their square. Okay, so this value is coming as 66.66. so this one is not correct. So this is equals to 60 point, so 1 by 4 into 66.66. 1 by 4 into 66.66, so divided by 4. So that is equals to 16.66. okay, now VRMS is square root of 16.66. so square root of 16.66, so that is equals to 4.082 volts. So this is your VRMS value. Okay, now what it is asking, so here again it is asking find the form factor and the peak factor. Okay, so what is the form factor now? So form factor is equals to VRMS divided by V average. Okay, that is equals to 4.082 divided by average value, how much we got? 3.75. So 4.082 divided by 3.75, so that is equals to 1.088, and then your peak factor is equals to, so Vm or the peak value divided by the RMS value, so that is equals to Vm is how much? Vm is, you can see here, so 5 volt is the Vm, so it will be V divided by RMS is 4.082, so 5 divided by 4.082, so that is equals to 1.03. so this is how you can solve this problem. So while solving, please make sure that you do this integration correctly and double check it, so that you won't get it wrong. So that's it from this video. Thank you.